Hello, everyone. This is Mike Adams, and I'm going to provide you a briefing today on the Maintenance Decision Support System Pooled Fund study that is currently ongoing. You see the map in the upper right corner of this screen showing all the states that are currently members in a darker shade of blue. A lot of upper Midwest states are part of this pooled fund, but as you can see, there's also states scattered around in what might not be considered the snow belt, such as Kentucky and Virginia. Some of the other states that had participated at one time are shown in lighter blue. What's not shown on here is we do have 3 states currently exploring joining the pooled fund, and hopefully they will be able to do that because the more members we have, the better the research program is. At the top of the screen, you see the official designation of this pooled fund. It's cutting edge research that we're doing. This MDSS, which is the Maintenance Decision Support System, was originally developed by the Federal Highway Administration back in about 2003. Once they developed their prototype, they put it out to anyone who wanted to use it, and this pooled fund was formed to aid in that deployment. It provides a very convenient funding mechanism. Most of the states that are participating are using state planning and research funding. Some use operational funding, but everybody that's in it provides $25,000 a year, and that goes to the research of future deployment. The learning that goes on is exemplified in the image at the lower right of the screen. That was one of our earlier meetings, and you see a lot of different states around the table or in the conference room, I guess I should say. And these meetings provide excellent opportunity for these states to provide each other feedback and bounce ideas off each other and to develop a work plan for the contractor. Iteris is the contractor for the MDSS pooled fund. They work a lot directly with each individual state. They also work with the pooled fund at these meetings, and they it works backwards too, where the states, as part of their operations, are providing feedback to Iteris. The pooled fund has developed intellectual property. It's open source, but it's not in the public domain, and I'll talk a little bit about that later. But it is a nationally prominent forum to develop and deploy this technology. So why do we need a maintenance decision support system? You see some of the primary reasons here on your screen. Probably right at the top of the list, and I'm sure all of you have experienced this, is the rising demands of the travelers, and in some cases, many cases, the commercial carriers is becoming just it's driving transportation at the moment, and in terms of what these various segments want out of their highway system and the ability to get from here to there, no matter what the weather is. In terms of maintaining the highways, we've got higher labor, material, equipment, and fuel costs. The cost of salt keeps going up. The cost of fuel goes up and down, and we're always looking for ways to make use of those materials more efficient. Every DOT is probably experienced or is experiencing constrained funding right now. There's just only so much money out there, and we're all trying to do the best with that limited amount of money. MDSS aids in that effort by making winter maintenance more efficient. We also have a problem getting timely reports from the roads. And one of the key components of the MDSS is an MDC AVL system where you're actually reading the conditions of the road and feeding that back into MDSS. We'll talk a little bit more about that later on. A lot of weather conditions are very difficult to forecast, so the MDSS uses a very fine scale model to try to get down to that local level and predict these hard to forecast things like lake effect snow. The response of pavement to weather and maintenance treatments is obviously a very complex mathematical type problem, and MDSS tries to incorporate as many of these factors as it can in predicting what's going to happen when chemicals are put on the road. It also allows us to be able to introduce new chemicals and new techniques and see how the roadways respond to them. And then we come to a couple of these bottom ones, which probably could be a little higher on the list. The first is environmental concerns. Many states are experiencing issues between their departments of transportation and the environmental agencies. And that's due to the increasing levels of salt that are being found in the groundwater, in wells, and even in runoff into rivers. And the environmental agencies are basically forcing DOTs to cut back on salt use. And the DOTs in turn say, okay, well, we're going to use something like an MDSS to help us reduce that salt usage. And then we have staff turnover, size, inexperience, especially the inexperience. You have operators that have been on the job for 30 or 40 years and they know what to do and when to do it, and then they retire. And then you get maybe some 20-year-old guy in that position that's never done it before. They need some kind of guidance to tell them what to do out there on the roads, and the MDSS certainly provides that. MDSS is really at its root a scientific concept. If you know things like the road characteristics in terms of, say, traffic volume or the type of pavement or how many lanes it is, what the current conditions are, what the predicted weather is, how snow, ice, and chemicals interact with each other on that road surface, and you know how much resources in terms of manpower and equipment you now have, you can come up with mathematically what type of treatment to do, how much of that material to put down, and just as important, when to put it down. And not only that, you can look out into the future and predict these things out for the next 12 to 24 hours. This is what we're trying to model, and it's a fairly complex picture. It's not like there's a uniformity across the cross section of that road. We have the wheel tracks showing basically a wet pavement. We have slush in between and maybe even some snow or hard pack off to the sides of the roads. The MDSS is able to predict that entire cross section, not just say, oh, the road is snow covered. It provides imagery of a road or a simulation of the road, I should say, in terms of how it actually looks based on what has been done to it. I showed on the first slide the states that are involved in MDSS. This is just a little higher level of detail of several of those states in the upper Midwest. You can see that Minnesota DOT and Wisconsin DOT have fairly heavy deployments. The Dakotas actually do too. They just don't have the density of the road network that the other two states do. And then you see a state like Nebraska, which is more in the test phase of MDSS. One thing to note is all states pay the $25,000 up front. That just goes to the research. And then each individual state pays its own operational costs in terms of forecasting for these routes on a route by route basis. So the costs or the amount contributed certainly varies from one state to another. This slide shows just a sample screen off of MDSS, off the map portion of it. You can see this user has customized it to show precipitation type. There is a satellite image showing clouds in the background. If you look just south of the Denver area, you can see some little orange icons. Those are trucks that are out on the road at that particular time. If you mouse over one of those trucks, you get the information that the truck is reporting back into the system in terms of what materials they're putting down, whether they're plowing, how fast they're moving, all those types of things. If you look off to the left side of that image, you see a blue, heavier blue marking. That's a route that has predictions in MDSS. If you were to click on that route or any route that's shown, you would get something like this. This is a customizable screen showing some of the weather forecast criteria that MDSS outputs. One thing to note here is that it's certainly user customizable. You can put these graphs and charts in any order you want. This particular user put wind speed at the top. Obviously, they're probably concerned about some blowing and drifting snow. But you see the probability of snow, the snow accumulation, and the temperatures, all kind of typical weather information being shown here. This is scrolling down on that same particular view. And the thing to note here is the bottom half of the screen, where it's actually showing the treatment recommendations on that particular stretch of road. You can see within the red circle, the little things that say NaCl, that's recommending salt application. And if you mouse over that, it would give you the amount of salt to be put down. And you can see those recommendations go well out 24 hours into the future. It's also important to note, if you look to the left of the gray line, which is the current time in each of these graphs, you can see activities that have already been done on the roads. Salt has already been applied. That information feeds into MDSS and guides the future treatment recommendations. You also see two different rows of recommendations here. The first is what MDSS is recommending be done. The second is an alternative recommendation generated by the user. They are then able to compare those two recommendations and see which one works out better. In this particular case, you look at the road conditions at the bottom, and you can see that the road conditions are actually better under the MDSS recommendations than they are under the alternative recommendations. One of the keys to MDSS is mobile data collection. As I mentioned before, real-time data is getting into the MDSS through the AVL vendor. And these are just some of the criteria that get fed back in from the plow trucks that are out there on the roads. They know the location, obviously, and then they know the road temperature, the air temperature. You can manually report what type of precipitation is falling, whether the truck is plowing or not, and what type of chemical they're putting down. All those are important, not only to know in the real time, but to help the system forecast what's going to happen in the future. Of course, this is a fairly complex system, so training and evaluation of what you've done is highly critical. And one of the nice things about MDSS is it allows you to play back a storm after the fact. You can save that storm and then go back and look at it 2 or 3 years later if you want. Use it as a training tool. And I know many states do that. They save the storms and then they use them in training, say the next fall, to show the operators not only how the MDSS works, but you can also do winter training through that too, to say, here's what MDSS is recommending, here's how it worked out, and that MDSS is pretty accurate in terms of what treatments it's recommending on the roads. In some states, MDSS is also used in traffic management. Several state traffic operations centers are using various portions of MDSS to help them make decisions on signage on variable message boards and activities like that. There is a mobile application that has been developed as part of this pooled fund. It works both on an Android and an iPhone platform. Very simple interface. We decided that this was a critical thing to have because probably the people that use the system the most are the supervisors. And these supervisors spend a good bit of their time during a storm actually out on the roads in their vehicles, and they don't have access to a laptop or a desktop computer, obviously. but they do have access to this mobile version where if they pull into a parking lot, they can pull up the various information, the treatment recommendations, and basically get the same information they would if they were sitting behind their desk in the office. South Dakota's actually taken MDSS one step farther. They are using it as part of their traveler information system. And in the eastern part of the state here, you can see where they're actually highlighting routes. This is a public interface now, highlighting routes where there could be some problems on the roads. Now, the highlighting is done in fairly general terms because forecasts can go wrong or a treatment can go wrong, and they don't want to say, oh, there's not going to be a problem, and then there is a problem. This is just alerting the public to places where the weather combined with the treatments might lead to some issues on the roads. The big effort that the pooled fund's involved in right now is developing a web MDSS. That's going to be deployed this fall. The current version is a desktop version that was developed about 12 years ago, before internet or high-speed internet became extremely popular. So the web is now the way that most information is transmitted. We are transitioning to more of a web-based system, and as I said, that will be deployed this fall. We're still continuing to explore how to integrate mobile data into MDSS. That's already been done, but now there's different types of data. We're even keeping an eye on efforts in connected vehicles to see if that might have some promise to feed into MDSS at some point. Another huge aspect of MDSS is management reports. Many states are using the data from MDSS to create reports based on objective data rather than subjective data from the field. For instance, in Wisconsin, we had been using a winter severity index that relied upon reports from the field after every storm about numerous criteria that storm might have produced. Now, excuse me, now we're able to use MDSS to generate that, and it produces a much cleaner look at winter severity. The MDSS pooled fund has created intellectual property. Each state is entitled to that intellectual property as long as they had been a member of the pooled fund for a certain length of time. So if a state wishes to take the software and deploy it on their own, like one state has already done, they are entitled to do that. The benefit cost on MDSS ranges anywhere from 3-to-1 to 8-to-1 based on a study by the Western Transportation Institute. Indiana DOT did a study of their first year deployment and looked at some of the figures that you see here on the screen in terms of how much money, material, and staff time they were able to save. And Minnesota DOT did a study a couple of years back where they said they had saved over $8 million in a particular winter comparing MDSS operations to what they had done before they used MDSS. So there is definitely a benefit to using this type of technology. That concludes this briefing on the MDSS pooled fund. I will be attending the peer exchange, so if you have any questions, please feel free to track me down, and there will be other members of the pooled fund available also. Thank you.